Good morning, students. So I am here today with our lecture number 8 for our course EE555 Renewable Energy Systems. So here is the overall introduction of the course that we discussed in our first two lectures, and today we will formally start with this portion. So wind energy conversion system, we will be mostly focusing on this particular portion. Okay. Uh, what are the intended learning outcomes for this particular lecture, lecture number 8? So, we expect that by the end of this lecture, you will be able to realize the importance of wind power technology as a renewable source of energy. And secondly, and more importantly, you will be able to identify and categorize various components of wind energy conversion systems. And the details of these wind energy conversion systems and their components we will cover shortly. So before jumping into the contents of the lecture, first I will discuss with you the learning material that you will be needed to cover the lecture contents. So the first learning material that you can use to comprehend the concepts that we will discuss today is the lecture 8 PPT slides that I am going to upload now on the Moodle. Then you will be able to also access the video lesson in which I'll explain the structure, contents, and concept of wind energy conversion system. And for the reading, you can study the chapter 2 from distributed generation systems by Musawi. So I'll ask Usman to upload this particular chapter on Moodle as well. Okay. So for me, starting with the wind power. So as we discussed in our first lecture, that wind power, it actually comes from sun. The main source of wind power is sun. So as a result, when wind blows, we can extract that energy and we can use that energy to produce electric power. So, what is the concept? The wind energy is actually a kinetic energy, and that kinetic energy is translated into rotational energy of the plates, and that rotation is then used to actually run the generator, and then generator produces the electricity. So, this is the simple and very basic concept for wind energy conversion system and how electricity is being generated from wind power. So if there is only one wind turbine, so we can call it a wind turbine conversion. But if there are multiple wind turbines that are connected in series or parallel, so that makes a wind farm. So in order to generate more output, the more power, and in the range of megawatts, we need to connect more wind turbines in series and parallel with each other to make a wind farm. And again, then we discussed that there is a possibility that wind farms can be onshore as well as offshore. So both of these wind farms, they have their own benefits and some of the advantages and disadvantages. We discussed these advantages in detail in our last lecture. So I will just give you a brief overview of these advantages: that it is free, it produces no waste or greenhouse gases. The land beneath it can be easily used, even if it's offshore. So you can even save the land space, and then they are very attractive in looks. So they can also be used as a touristic attractions. As in Holland, there are a lot of wind farms, and they are used as tourist attraction. And then again, where there is no electricity or electric grid available, this can be the best solution. You do not need to lay the long distance transmission line, which are highly costly, as well as they cause a lot of line losses, power quality deterioration. So all these things can be avoided for the remote areas, and directly wind turbine can be used there as an energy source. So the disadvantages, there are few disadvantages based upon the type, but these disadvantages, they are limited compared to advantages that we gain from wind power. So now we will discuss in detail about the wind turbine components. So any wind turbine energy system that produces energy, electrical energy from the wind, it contains the following components. The first and the most important component is the rotor. Then we have pitch controller mechanism. We will discuss shortly what is a pitch, what is a controller, and how this mechanism actually drives. Then we will discuss gearbox mechanism, how gearbox actually helps achieving the high speed for our wind turbine generators. We will also discuss brake system. For instance, if you need to stop your wind turbine at a given condition, just suppose for the maintenance, so brake system will come into action, and as a result you can actually stop your wind turbine. Then the most important components, because we are electrical engineer and we are studying electrical engineering, so from engineering point of view, the generators are the main and fundamental components for electricity generation in wind turbine energy conversion systems. Then we will discuss anemometers and wind vanes. Then we will discuss yaw system, which is also used to control the direction of the wind turbine, and in the last we will discuss towers and foundations for wind energy conversion system. So now I will go into detail of each topic one by one. So before going into the details, I would like to show you a general overview how a wind turbine system looks like. All the components that I discussed in the previous slide, here you can see them in a pictorial form as well. And this is Bosch wind turbine, whose picture is you can see over here. So here, if you see, this is your pitch mechanism that we will discuss shortly. Then we have these are our rotor blades. Rotor blades, these are also very important components that convert rotational energy into kinetic energy into rotational energy. And then we will also discuss what is meant by this low speed shaft, and here it has high speed shaft. Then we will discuss about gearbox, the braking mechanism, the most important component for electricity generation, which is a generator. And last but not the least, these are power electronic converters then that are used to convert voltages and power quality, maintain the power quality. This is the rotor hub. This is yaw drive mechanism. So we will discuss the yaw drive mechanism. Tower that carries all of this stuff, and this nacelle, this is frame or the housing which contains all of these aspects. So these are the main components. You have seen their pictorial representation as well. Now it will be easier for you to when I will discuss these mechanism one by one to understand and grasp the concept. So here is another overview for you guys, just to have more pictorial representation, the more details into the concepts before we go into the detail of the individual topics. Here again, you have blades. Generally, a wind turbine can be 1, 2, or 3 blade system. We will discuss it in detail. Then we have a rotor. Rotor is something, an assembly which rotates. Then a hub which contains this rotor. Pitch mechanism, we will discuss shortly. Here, based upon the wind direction, we can actually adjust the direction of these blades, the angles, as well as the direction of overall wind turbine. So the wind direction, this will also be measured, but this will be measured through some sensor which we'll call anemometers. Then there is a brake to stop your turbine instantly. There is yaw drive, yaw motor. This overall mechanism is called a yaw mechanism. So I write it as yaw mechanism. Sorry for my bad handwriting. Tower which carries all this stuff. Then we have generator nacelle, which is the hub that contains every of this thing. In the last, we will also discuss this wind vane and anemometer mechanisms. These are used to detect the direction and speed of the the blowing wind. Okay, so now I will go to the first part, which is rotor. Now, rotor, it actually consists of two parts. The first part is rotor hub, and the second part, and the important part, is blades. So, blades, they actually convert kinetic energy into rotating motion. How does this work? How they actually convert the kinetic energy into rotation energy? This is something you can take its analogy from the airplanes. In airplanes, you have wings, which are actually the blades here in case of wind turbines. So these blades, they are mechanically designed such that they work on the principle of pressure difference. So pressure difference exists between the lower surface and the upper surface of the plate, as a result of which there is something we call lift is produced. But the important thing here are the blades. So these blades, they must be strong enough to withstand the pressure of the wind, and that's why they are made up of either aluminium alloys or some other fiberglass, which are very strong to withstand the wind pressure. And then the other important thing is that other than achieving the strength, we also need to see the weight, because if the weight will be too high, then it will be difficult to rotate with the given wind speed. So we have to optimize this weight to strength ratio in order to have a better wind turbine. Then from the historical perspective, the design of the blades that evolved with respect to time. First of all, when wind turbine started, it was one blade, then it moved to two blade and three blade. As you increase the number of blades, actually the speed, it decreases. With the lower number of blades, speed actually increases, but it has some other drawbacks. For instance, when there is only one blade, so all the mechanical force and all the mechanical disturbance that disturbs and overall balance or uniform distribution of air is not there. So in order to achieve the uniform distribution and to minimize the overall imbalance of air, we need to have higher blades mechanism. And generally nowadays, three blade is a standard that is being used almost by all of the wind turbines and wind turbines manufacturing companies. So higher blade ratio, lower is the speed, but more balanced mechanical load distribution and less stress on components. Because if there will be more stress on the components, it will also reduce their lives, and there are chances that gearbox and other components which actually experiences these stress, they may undergo damage. So now here we can understand how actually lift principle works. So the first thing that you need to understand is the pitch angle. And it is also called attack angle. For instance, this is the direction of the wind. Here it is the direction of the wind, like this. And so you can also see here, this is the direction for the wind flow, and this is the axis. Here you can see this is the chord line of the blade, and this is we can on axis of the blades. And then here the angle between wind flow and this axis is called angle of attack or pitch angle. I can change this angle. By changing this angle, I can actually adjust what will be the pressure over this surface on the top surface and what will be the pressure on the lower surface. Now, what is the principle of Bernoulli? Bernoulli's principle states that if you have higher speed in a fluid, the pressure will be lower. And if you have lower speed in on a fluid surface, then pressure will be higher. So by this mechanical distribution, what we do, we actually create higher wind speed on the top surface of the plate, as which results in lower pressure. Similarly, we create lower speed on the bottom surface, as a result higher pressure. So because of this pressure difference, which is lower on the top surface and higher on the below surface of the plate, so you consider the surface of the plate, pressure is higher on the top surface and pressure is lower on the bottom surface. This pressure difference causes a lift. This is exactly the similar mechanisms they follow in the aeroplane lift. So this is exactly followed by our wind turbines as well. So the pressure difference causes a lift, and that lift actually produces rotational energy, and that rotational energy we can further use for the production of electricity from the generator. Okay, now move to the second thing, which we call pitch and controller mechanism. So I define you, this is the pitch angle. So if what will happen if I make this line exactly parallel to this line? So this angle will become 0. The angle between this and this line will become either 0 or 180. So whenever these two axes, they will be aligned, as a result of this, what will happen, your turbine will stall. It will not, the pressure difference, this will become 0. And when the pressure difference becomes 0, because the speed is now uniform on the top and bottom surface of the blades, as a result there will be no rotation and no electricity production. So this pitch mechanism actually controls the angle. So by controlling the angle, we control the speed on the top and bottom surface, and by controlling the speed, we actually control the pressure, and by controlling the pressure, we can change the conversion ratio from kinetic energy to the rotational energy. But how we change this angle? This is the mechanism. The mechanism is called controller pitch controller mechanism. Uh, through So pitch is defined as the moving portion of the blade, and by rotation of the blades on their longitudinal axis, we can increase, decrease, or even stop the turbine by just changing the angle, just as we do in the aeroplanes. So there is a possibility that there is very low speed, and at other times there is a windy condition. So when there is a very low speed, so we adjust the pitch angle such that we extract the maximum power out of it, while in the windy or storming conditions, when there is a storm, we can stop or stall the turbine so that there is no mechanical damage. We can use single or multiple blades. We can control them simultaneously or in different at different times, and there is a backup supply to actually feed this controller mechanism. The next important component is the gearbox. So when I say gearbox, it means it connects low speed shaft that I showed you in the start of the lecture, and it connects the high speed shaft together with each other. This wind speed, it is very low. In general, you see it's generally 6 to 20 rpm. So this speed is not enough to run this generator to produce a frequency of 50 hertz. As a result, what happens, we have to have a gearbox which actually converts this low speed into a high speed, and this gearbox is then used to create that high speed. We will discuss this in our coming lectures about this our mechanism, how we generate 50 hertz or 60 hertz using generators and using this gearbox mechanism. But here you can see the overall pictorial representation. It contains high speed shaft connection, and there is a low speed shaft connection. Since This includes a lot of gear change, so we have multiple stages rather than having it in one stage and having more mechanical pressure. We do it in first, second, and third planetary stages. Generally, our gearbox, this is made up of steel. We have It's the most noisy component in your wind electric power conversion system, and also it's the most costly component, and it causes many wear and tear, and we need to have its maintenance timely. There is an other possibility that we have single stage or gearless. We remove the need of this gear such that the speed of the wind turbine, it actually matches the speed of the generator. So we can have this mechanism as well, but this is not preferred. We generally, in practical systems, we generally go for a gear-based mechanism. Then we have mechanical brake system. A mechanical brake. So one possibility is that I have a storm, and the other possibility is that I have to do some sort of maintenance on our turbine. So I have to stop it. Even if wind is blowing, I need it to get stopped. So in that scenario, we apply mechanical brake. So mechanical brake, it actually stops the system, or even it controls the speed of the system. Rather than applying brake when the machine is operating at its full speed, we first apply the pitch control mechanism, and by using pitch control mechanism, I decrease the speed, and then I apply the mechanical brake, so I can limit the wear and tear within the system. These brakes, just like our cars, these are disc brakes, but the mechanism can be hydraulic or mechanical. Both type of mechanisms are being used in practical turbines. So we generally use to apply brakes at lower speed. First, how do we achieve the lower speed? We achieve the lower speed using pitch mechanism, and then we apply. So here you can see the pictorial representation for your turbine, for your braking system. Then there comes the most important component, that each of this component we will study in detail in our upcoming lectures, not in today's lecture. But I'll give you the overview. Most of you would have studied about the course of electromechanical systems, and there you would have covered induction machines and synchronous machines. We will cover their generator parts. So squirrel cage, the first one, squirrel cage, it does not have any rotor. It does have a rotor, but that rotor is made up of aluminium bars and filled with a ring, so it looks like a squirrel cage. That's why it's called a squirrel cage machine. And we will see that induction principle, how it applies over there, and how we can generate electricity from squirrel cage induction generator. Then there is a possibility, rather than having the steel or aluminum bars, we have a winding, and so this is called wound rotor induction generator. It can be available both in induction as well as synchronous configuration. Then the fourth one, this is the most important type of generator, this doubly fed induction generator, that we will discuss in detail. It has two windings, field winding as well as armature winding, and both are fed. That's why it's called doubly fed induction generator. And last but not the least, this is being used nowadays it's called permanent synchronous generator. So rather than having a winding, we have a permanent source of magnet to provide the field within the generator. We will study all of these in detail in our upcoming lectures. Here you can see their pictorial representations as well, with the stator and rotor configuration. The next component is yard drive system. So first thing we discussed about blades. We control the speed of we control the position of the blades. We control the pitch angle, and we can actually control how kinetic energy is being converted into rotational energy. But one thing is the control through the blades. The second possibility is, rather than moving the blade, what if I move my whole turbine, left and right, to get it adjusted with the wind speed and wind direction. So with the wind direction, especially with the wind direction, we rather than changing the blades, because blades change, the change in the pitch angle, that can provide us maximum power point operation up to a certain range. Other than that, we have to move the direction of our turbine itself. So the mechanism that we use here is called yaw drive system, and it contains motor drive, yaw gear, gear rim, and bearing. And it can also used for power curtailment. By power curtailment, I mean, rather than applying the brakes, we adjust the position such that it becomes parallel, and there is no electricity generated. There is no wind that creates pressure difference between the blades. But this is not this power curtailment mode is not used nowadays using yard drive system. Rather, we use pitch system that we discussed earlier. The seventh component is the towers and foundation. And when I say towers, I mean that support which carry nacelle and as well as rotor. So everything is exist on the top. And in this nacelle, generally, this also contains the generator. So carrying the generator and supporting it, this tower should be of significant strength, and it should also provide the given elevation to achieve the better wind speed. So as you go on height, wind speed keeps on increasing and getting better, and you can get more production. We will study more about how height affects the wind speed and how wind speed actually affects the power generation in our coming lectures. This tower can vary in the length of their in the range of their length. It can vary from 25 to 160-meter height. So as this height increases, so does we need the support and foundation on the bottom. So it needs to be more strong. So with the increase in the height, we need more strong foundation, varying from gravity to floating foundation. Since these things, they actually they are more concerned with the structural engineers who study how the vibrations of rotor or the moving wind turbine affects the surface on the earth and the tower. So they study about vibrations, their analysis. But being an electrical engineer, we generally don't focus on these aspects, but you should at least know these components, that how actually height affects these components. The last component, this is the last but not the least, because all of our control system is based upon these sensors. So anemometers and wind sensors. So when I say wind sensor, it senses two things. One thing is direction, the other thing is its speed. So speed and direction measurements are done through it. Speed measurement is used for pitch control system, while direction, as I discussed earlier, is used for yaw control mechanism. And with the yaw control mechanism, you can actually change the direction of your whole wind turbine, and with the pitch control system, you only change the direction or angle of the blades. How does this work? This is a cup type structure. So when wind blows, it rotates, and we can count the number of rotations on a counter. As a result, we can measure the average speed, and then there can also be a wind vane which gives you the direction of the wind. Actually, very simple, self-explanatory video for the understanding of how anemometers and wind sensor works. But the most important thing is that you should know that these two inputs are used for the control system on your wind turbines. So this is all about all the components of our wind energy conversion system. Now I will expect you to see this, to watch this video, and we will discuss your particular question in our lecture timing. Thank you.